It's time to get real with math, throw in a bit of imaginary numbers, and we have ourselves a complex number question. Now, it looks a bit complicated. However, the solution is very elegant and very, very satisfying. So let's get started. We have a complex number omega equal to cosine of 2 pi over 2025 plus I sine 2 pi over 2025. So I want you to find the value of this product. Now, note that I used this notation to condense the product over here. If you do not understand this notation, then don't worry about it. Just use the one that just use the more expanded version up here. It will not put you at any disadvantage whatsoever. So, firstly, I want to make it clear that I am not going to be substituting omega into the expression and computing by hand. I am not doing that. There are 2024 terms over here. No. So we have to think of a more elegant solution. Well, firstly, note that when we have a complex number in the form cosine theta plus I sine theta, then it can be shown that this is equal to e to the I theta, where of course this I is still the square root of -1. So this complex number is simply equal to e to the 2 pi over 2025 times I. Okay, so we have made our complex number a bit more compact. Now, what's the next step? Well, this next step might seem a bit arbitrary. However, at the end of it, if you find it arbitrary, then trust me, by the end of the video, you will see why we decided to make this leap. As of right now, if it seems random, then just bear with me. You will understand at the end. We're going to consider the polynomial f of x is equal to x to the 2025 minus 1. Now, what are the roots of this polynomial? Well, they are the 2025 roots of unity. So, in particular, and if you don't understand what roots of unity are, I'll briefly explain later. But as of right now, the roots of this polynomial are basically e to the I times 2k pi divided by 2025, where k iterates from 0, 1, 2, all the way to 2024, the 2025 roots of unity. In case you are a bit not familiar with this concept, well, basically, when we have a polynomial of the form x to the n minus 1, where n is some positive integer, then the roots of this polynomial, by the roots of unity, they are e to the I times 2k pi divided by n, where k iterates from 0, 1, 2, all the way to n minus 1. So in the case for 2025, it goes up to 2024. So that's roots of unity. Now, what was the intention of getting the roots? Well, notice that if they are the roots, then notice that we can write this in factored form. So I'm going to quickly clean up our incoming equations by introducing a new variable. Firstly, notice that I can basically take out this k, right? I can take out the k out of the exponent. And I'm going to let the complex number z equals to, well, actually, first off, notice that this complex number, e to the I times 2 pi over 2025, it's equal to omega, right? So actually, this complex number over here is just equal to omega to the k. Now, notice this. Because these are the roots of this polynomial can be written as a factored form. In particular, it is x minus 1, so that's when k is equal to 0. As you can see, that becomes 1. And then k becomes equals to 1, so that'd be omega to the 1. So that's x minus omega. And then when k is 2, this would be omega to the second power, or square, of course. And it goes on and on all the way to the 2024 power. So this would be x minus omega to the 2024. Now, look at this. It looks awfully similar to this expression. But first of all, notice that we have a plus omega inside the brackets. But here we have minus omega. And of course a minus 1, but this does not matter. We can just divide it out easily later on. But the point is that we want a plus omega, so we might as well factor out negative signs out of each of these factors. Now, how many factors are there? There are 2025 factors, because if you just go from 1 to 2024, yeah, that's 2024, but this extra 1 counts as 1 more. So we're going to factor out 2025 negative signs. So factoring them out, because it's an odd number of negative signs, it will be negative. And then inside each of these factors, we take out a negative sign. So that's negative x plus 1. Oh, sorry, plus 1. And then this would be negative x, and then plus omega, and then negative x plus omega squared, and then so on and so forth, all the way to negative x plus omega to the 2024. Now this is much better. It looks a lot more like this. Now notice this. I'm going to first erase the board because we're kind of short on space. So, okay, so now notice this. Again, as I said, this looks very familiar with this. Notice that if we were to plug into this expression, if we were to plug in x is equal to negative 7, this product basically becomes almost identical to this one. Of course, we still have a negative x plus 1 and this negative sign. But the point is that it's pretty much identical to this. So if we plug in x equals to negative 7, we have our almost identical expression. But here's the thing. We do not have to evaluate this expression using this expression. We can just use this because we proved that this is equal to this. So plugging in x equals to negative 7, this would mean that when x equals to negative 7, this expression over here, I'll draw an arrow, this is equal to negative 7 to the 2025 power. It's an odd power, so it's still negative. So negative 7 to the 2025 minus 1. Now, again, notice that we still have this extra negative sign and a negative x plus 1. Well, first of all, this negative sign still stays here, but then plugging in x equals to negative 7, we would get negative of negative 7, that's 7 plus 1, that's 8. Now, notice that our answer is off by a factor of negative 8, right? All of these other terms, the other terms over here, which I'm going to underline, this entire thing with x equals to negative 7 is exactly what we want. So our answer is off by a factor of negative 8. Therefore, our answer, we just need to divide this by negative 8. And that's our answer. This is our answer. So I'm going to erase that negative sign and box our answer over here. This is the answer to our question. Now, of course, we could make this a bit more, less ugly by taking out the annoying negative signs by multiplying top and bottom by negative 1. And this would be our formal answer. I do not need you to evaluate this numerically because this is a very, very large number. I would not expect a numeral as an answer, so this is already good enough. Now, I said that you would understand why we decided to consider this polynomial at the start. Well, notice, because this this complex number omega is equal to e to the 2 pi over 2025. And we saw that the roots of unity were of the form e to the I times 2k pi over n. And when you factor out that k, right, take out that k from the exponent, take that out, you see that this is pretty much identical to this. And you can see that when k goes from 1, 2, 3, all the way to 2024, they are exactly the 2025 roots of unity. And if they are the roots, it gives us a factor form, which almost looks like what we have over here. Before I end off this video, I do want to say that this method of making connections between some expression with the roots of unity is a very common tactic in evaluating complicated expressions with complex numbers. And it's actually pretty common in math competitions. If you want to, you can go ahead and try any of the 3 problems I've posted here on the screen. I think they are great exercises to kind of build off from what you learned from this video. So yeah, with that being said, I hope you enjoyed this video. I hope you found it interesting. If you did, please consider dropping a like and subscribing. Thank you very much. Bye.